Alright, so welcome to this video. This is video 2.6. We're going to be looking at terminating, recurring, and rounding decimals. So essentially this is three different types of decimals that we're going to be working with this term. And as you should already know, fractions and decimals are essentially the same thing. They're just different ways of representing some point on the number line. Okay. However, not all fractions will behave the same when converted to a decimal. So as I said before, there are three different types of decimal behavior. We have terminating decimals, recurring decimals, and rounding decimals. So these two here are more types, and this one here is a process that you need to go through. Okay, right, let's have a quick look at these. Again, using your calculator makes this so much easier. However, you do need to be able to do it just sort of off your head quite quickly. You don't have to worry about using your calculator to round stuff. Right, terminating decimals. These are sort of easy ones. Not going to spend a lot of time on it. When the division represented by a fraction is carried out, the number has a finite number of decimal places, which that is to mean it terminates. So if we look at 7 divided by 8 on our calculators, you just chuck that in, you'll see that, so don't forget that 7 over 8 is the same thing as 7 divided by 8, which if we chuck in our calculator, you'll find it is 0.875. Okay, the decimal number finishes there. There are no more to come after it, so that's why we say that it terminates. Okay, that's where it finishes. No more to come after it. There are so many decimals where things go on forever, so it's important to realize that these are terminating decimals. Okay, right, not a lot of interesting stuff to see there. That's really that. Right, next one, recurring decimals. So when the division represented by a fraction is carried out, the number has an infinite number of decimals that contain, this is the important part, a repeated set of numbers. Okay, right, we acknowledge this repetition using dots or a line, and I'll show you sort of how that works. Right, the first one we're going to have a look at is 8 divided by 9, and you'll find that on your calculator, if you type that in, you will get, so 8 over 9 is equal to 8 divided by 9. And if you chuck that in your calculator, you get 0.88888, a whole bunch of 8s, and then a 9. And now what this suggests to us is that we have a recurring number. Okay, and the way that we demonstrate that using mathematical language rather than writing out an infinite number of 8s following after each other, this 9, you'll see later on, this 9 is just a rounded number. Okay, so 8 over 9 is equal to 0.8 recurring. Okay, so there's that little dot there. This little dot tells us that this number 8 goes on forever. You could also write it as 0.8 with a line over the top. This also is the little line I was talking about that demonstrates that that 8 is the one that keeps on going forever. Alright? Now, a notorious number for getting repeating sets of decimals is dividing by the number 7. So if we chuck 5 divided by 7 into our calculators, we will get, and you might need to push your arrow conversion button to get to see this, but 5 over 7 is the same as 5 divided by 7. And if we chuck that in a calculator, you'll see it is 0.71428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428571428. Right, so you might be noticing something going on is that if we look at this, you'll notice some numbers being repeated here. 7142885. Right, so you might be noticing something going on is that if we look at this, you'll notice some numbers being repeated here. 714285, here it is again, 714285, and here it is again, 714285. So they are our recurring numbers, and it's recurring in a pattern. So there's two ways that you can demonstrate this. You can use the dots to demonstrate that we are repeating from here to here, right? And so you would write 0.714285 and then put a dot there and a dot there to show that that set of numbers repeats forever. or you could write it as equal to 0.714285 and then put a line across the top. Okay. Personally, I prefer the line way because I just think that it's a little more neat than sort of dots going on. Line sort of suggests straight away there's repeated sets. It's up to you which way you do, it doesn't really matter. Okay, but that's how you demonstrate repeated sets of numbers. So when you type things in your calculator, especially for fractions, it's a good idea to check to see if you haven't got recurring decimal places. Right, lastly, terminating decimals. This is actually meant to be rounding decimals. So let's just change that. Rounding decimals. So in most circumstances, okay, this is true for especially for the sciences, it is unnecessary to report all the decimal places in a particular number because we don't want to know the 50th decimal place of 5/7. It's irrelevant. It's so small and insignificant that it doesn't really have a physical quantity and we don't need to worry about it. So it's unnecessary to report all the decimal places in a particular number. Therefore, we will approximate the number by rounding to a certain decimal place. So this is a sort of key term that you need to know what it means. Okay, we're going to look at that in a sec, but rounding is something you need to remember. So the process for rounding is as such. You first inspect the critical number. Okay, that's the key term too, critical number, which is immediately to the right of the decimal place you are rounding to. Maybe that doesn't make a lot of sense when you're reading it like that, but when you see it worked out in a moment, you'll sort of get what's going on. If the critical number is, now there's two possibilities here. Firstly, if it is between 0 and 4, then you just simply terminate the number at the rounding decimal, and we'll see how that sort of turns out. And alternately, if the critical number is between 5 and 9, then you increase the rounding decimal by 1 and then terminate the number. Okay, so you'll see both these circumstances happening in this rounding in a sec. So if you didn't quite understand what they meant as sentences, sort of have a look as we go through some of these examples. Right, first, round 45.675 to 8 through to 3 decimal places. So let me just blow this number off here a bit so you can see it a little better. Right, so round 45.675 to 8 to 3 decimal places. Right, so decimal place 1, 2, 3, and so this is where we're going to be terminating in the end. Okay, so as per our suggestions before, we inspect this number, the critical value, which is just to the right. Let's have a look at it. So the critical number is 2. Now, according to our steps, if the critical number is between 0 and 4, we leave the number alone and simply terminate at the rounding decimal place. So, therefore, 45.67528 is approximately equal to, that's what that little sign means, I'll sort of fix that up, approximately equal to 45.675. Okay, so essentially what we're saying is this 28 here doesn't even matter. Okay, it's insignificant. It doesn't matter in comparison with the rest of it. Sort of think like if someone was to say, how far is it from school to the inner city in Brisbane? You wouldn't say it is, 30, 40 kilometers, 10 meters, 5 centimeters, and 6 millimeters. No one cares about the 6 millimeters. No one probably even cares about the 10 meters. It's more so the kilometers you're worried about, so you would round up to the nearest kilometer. Here we're rounding to the nearest to 3 decimal places. Okay, right, next example, round 1.48 to 1 decimal place. So let's blow this up a little bit so we can have a little bit more of a play with it. Right, round 1.487 to 1 decimal place. So we count in 1 decimal place, and we know we're going to be terminating here at some stage. Okay, so we inspect our critical number. Let's have a look at it. It's an 8. Right, 8 is our critical number. Therefore, according to our little steps before, if it is between 5 and 9, which 8 is, then we increase our rounded number, our rounding decimal by 1, which is this one here. That's our rounding decimal here, the number 4. We increase that by 1 and then terminate the value. So let's have a look at that. Therefore, 1.487 is approximately equal to 1.5 and then terminate it. Okay? So, because the critical number was 8, it means that our 4 goes up by 1 to a 5 and then you terminate the decimal. Okay? So that's the second type of one. Right, here's one that's a little more tricky. Rounding 0.1964 to 2 decimal places. Just blow this up a little bit. Right, to 2 decimal places now. So, 2 decimal places, 1, 2. That means we're going to be terminating here at least. Right, let's look at our critical value. Is a 6. Therefore, increase the rounding decimal. Okay, so let's do that. 0.1. Hang on, if I increase our 9 by 1, what happens? 9 plus 1 is 10. So, in this instance, we're still going to terminate here. We're still going to terminate at 2 decimal places, but instead 0.1964 is approximately equal to 0.20. Okay, because you can think about it that we have 19 here. Okay, 19 plus 1 is 20. Okay, so we needed 2 decimal places, which is why I still have 2 decimal places in my answer here. Okay, so that one's a little tricky. You'll get plenty of opportunity to practice those ones and make sure you get on top of those ones there that are a little bit different, but essentially these rounding decimal stuff is quite easy, and I hope you're able to get onto it quite quickly. Please ask me any questions in class if you had any issues with some of the stuff in this video. Okay, thanks for watching.